Now we go for the identification of the reduced form equation. Let us take one of our models, that is Q is equal to alpha naught plus alpha 1 please plus alpha 2 y. P is my price, Y is my income, and this is my demand function. And your Q is equal to beta naught plus beta 1 P plus beta 2 R, and R is my supply function, where say your R, this is my supply function, this is QD and this is QS. So R over here is say rainfall. Your supply is, our agricultural product supply is very much depending upon rain, so we can take that. Here, what are the endogenous variables? We can say P and Q will be the endogenous variables, and Y and R are the exogenous variables, and we assume that they are independent of the error term. However, the endogenous variables, they may be correlated with the error term. Now, since P and Q are endogenous, so we have seen that if we apply OLS, we will be facing, we have seen that the covariance is not equal to 0, the estimated are biased, unbiased, are biased and not consistent. So now, in order to estimate, what we do, we equate the demand function with the supply function. This was my demand function and this is the supply function. Then we try to bring all the terms, this is P1 and this is P1. We try to bring these terms, we take it over here and the remainder goes over here. So we can write it in terms of P, beta 1P minus alpha, beta 1P minus alpha 1P is equal to this entire remainder, that is minus beta naught minus beta 2R minus U2 plus alpha naught plus alpha 2Y plus UI. Now herein we can take P common. So once we take P common, we have P bracket open, my beta 1 minus alpha 1 is equal to minus beta naught minus beta 2 R minus UT plus alpha naught plus alpha 2 Y plus U1. Now we take this term to the denominator of the right hand side. So P is equal to, now P can be finally written as, and we take the things common over here, we arrange the things, so it becomes alpha naught minus beta naught divided by B1 minus alpha 1, alpha 2 divided by alpha 2y, alpha 2y divided by beta 1 minus alpha 1, and beta minus beta 2r divided by beta 1 minus alpha 1. We take all the error terms together, that is u1 minus u2 divided by beta 1 minus alpha 1. So now we have the terms. So what we do, we write this equation as alpha 10, this equation as alpha 11, not equation, these terms. This term as alpha 10, this term as alpha 11, this term as alpha 12, and this term we simply write it as Z1. That's what, this is the reduced form for the price. And this is the same thing, alpha 10, what is alpha 11, what is alpha 12, and what is Z1. What we have done from here only, we have got these terms for alpha 10, pi 10, pi 11, pi 20, pi 12, pi 10, pi 11, pi 12, and Z1. Now we are solving this for our equation 1. What was our equation 1? It was our demand function. We are solving it for our demand function. The value of P is written over here. This is the value of P which we have just now derived. So we write the entire value of P and we put it plus alpha naught plus alpha 1P plus alpha 2Y plus U1. Now we again, the same process which we have been repeating, we multiply all these terms with alpha 1. We got this term, this term, this term, this term. Then what we do, we take our y's together. We take our y's, this y term together, we incorporate our y term over here and we incorporate u2 over here, and we have then we get this equation. Upon doing this, upon incorporating y, we can write it like this. Then finally we take the LCM and incorporate alpha naught with the first term, and we take LCM and incorporate u1 over here. So this can be written as Q is equal to alpha naught beta 1 minus alpha 1 beta naught divided by beta 1 minus alpha 1 plus alpha 2 beta 1 divided by beta 1 minus alpha 1 y minus alpha 1 beta 2 divided by beta 1 alpha 1 r plus beta 1 u1 minus alpha 1 u2 divided by beta 1 alpha 1. This is what we have just now derived. Now, so again this term we define it as pi 20, this term we define it as pi 21, this term we define it as pi 22, and this last term we define it as z2. And those things are again written over here for your reference. So what we have done, we have now formed the reduced form of the demand equation. This is the reduced form of the demand equation which can be written in this format. So we got two equations. This was the reduced form for price and this is the reduced form for demand. So these pi's are called as the reduced form parameters, and now what we can do, we can use OLS. We can use OLS and find the values of pi 10, pi 11, pi 12, pi 20, pi 21, pi. We can find this value, this value, this value, this value on all this value. So now OLS can be applied to get the values of pi and estimate the functions and estimate the equation as a whole. Hope this method of estimation is clear. Now, for identification, we need to identify also first. So identification, we have seen earlier also that what is G? It is the number of endogenous variables in the system. How many endogenous variables are there in the complete system? K is the total number of variables, both exogenous and endogenous, missing from the equation in their consideration, but is present in the entire system of equations. What is the order condition? K, if K is equal to G minus 1, the equation is exactly identified. If K is greater than G minus 1, the equation is over identified. K means the total number of variables which are not present in that equation but are present in other equations. And K, if K is less than G minus 1, G is the total number of endogenous variables in the system. If K is less than G minus 1, the equation is under identified. These are the rules of order condition. These are the rules of the order condition. Now, in our example, we have got these two. Let us see the number of endogenous variable in the system, G. What are the endogenous variables? P and Q. The endogenous variables are P and Q. And the total number of variables, both endogenous and exogenous, which are missing from the equation under consideration, means we are suppose we want to do estimation for this, identification of this. So what is missing? It is R is also here, R is also here. So that is missing from the equation under condition K is equal to 1 in each equation. That is K is equal to G minus 1 and I is equal to 2 minus 1. Taken Y is equal to alpha 4 plus beta 4n plus u4, then we have defined n, that is the labor function. N is equal to alpha 5 plus beta 5w plus c5p plus u5, and then we take the labor supply function. N is equal to alpha 6 plus beta 6w plus gamma 6p plus u6. So we have basically defined consumption function, investment function, the identity, the LM function, a production function, a labor demand function, and the supply function. Now we will try to find out if these equations are identified or over identified or just identified. No, the third equation, which was our y is equal to, this equation is just an This equation is just an identity equation. So the order condition can be explained as G is the number of endogenous variables in the system and K is the total number of variables missing from the equation under consideration. And the order condition, you can write it as K is equal to G minus 1. The equation is exactly identified. If the K is greater than G minus 1, the equation is over identified. If K is less than G minus 1, the equation is under identified. We draw this table where 1, this letter 1 indicates the presence of the variable in that equation and 0 implies variable is missing from that equation. So we can see that in the C equation what are the things which are present. This is present in third equation, this is in the first equation. I is not there, N is not there, 0 is not there, R is there, Y is there, I is there, and likewise this system of equation from here, see C Y T R is there. So we can write C Y T and R is there. All other terms are not present in the first equation, hence they have been marked as 0. So the terms which are present, they are marked with the letter 1, and the terms which are not present are marked with 0, and the entire system of equations, this exact model is written over there, is written over here in the same format. 1 if it is present in that particular equation, 0 if it is not present. Now in the order equation, now we see there are 1, 2, 3, 4, 5, 6 and 7 equations and 7 endogenous variables. So we have this 7, G is equal to 7, and in our formula we need G minus 1, that is equal to 6. Now let us take one equation. We want to do the identification of one of them. So C is equal to alpha 1 plus beta 1 y minus gamma 1 t plus lambda 1 r plus u. Now how many k's are there? How many k's are there? K is equal to 6 and K is equal to G minus 1, that is equal to 6. So here it was G minus 1 is also 6 and K is also equal to 6. K. First K, second K, third K, fourth K, fifth K and sixth K. That is, I variable is not present, N variable is not present, P variable is not present, W variable is not present, G variable is not present and M variable is not present. Since these variables are not present, that this defines my K. And what is your G? G is the total number of equations and the endogenous variables. So we have 6. So now G is equal to 7 and G minus 1 is equal to 6. And how many variables are there in the system of equation which is not present in that particular system equation of C, but is present in remainder of the equations which are there in the model. So 6 is equal to 6. In that case, we can say that the model, that this equation is exactly identified. So this was the order condition for one of the equation to explain you one of the equations. Now we go to the next item. Here what we do, we are trying to see if the rank condition is satisfied or not. This is a very big example. We will take only one of the we are just trying to identify one of the equation, that is the consumption equation. Basically this table which you are seeing over here on the left hand side of the screen, that is in blue and in other colors of green and yellow, this table can be written in this format, and let us see how it is done. Since we are doing the identification process of the consumption equation, which happens to be our first equation, we delete the entire system first. Second, we pick up the columns of missing variables. The variables which are not present in C but are present in other, meaning thereby the variables which have a 0. So we have 0 in 1 in I, we have 0 in N, we have 0 in P, we have 0 at W, we have 0 at G, and we have a 0 at M. So we will be picking up these equations, then we write them in a separate matrix. So we have 1 is written, N is written, P is also written, R is not taken because R has a value 1, Y is not taken because Y has a value 1, W is written over here, G is written over here, T is not written, and M is written over here. So we have made another matrix using the columns which were having a missing variable for the equation C. Now we get G minus 1, that is equal to 6, after deleting first equation coefficient and including variable column in equation 1. We have 6 rows, 1, 2, 3, 4, 5, 6, and 6 columns, 1, 2, 3, 4, 5, 6. So we have 6 rows, 1, 2, 3, 4, 5, 6, and 6 columns, 1, 2, 3, 4, 5, 6, whose elements are not all 0. So hence the rank condition is also satisfied. So I hope with these two examples, your identification of reduced model, the concept for the identification of reduced model is clear to all of you. And obviously this identification of reduced model is a bit problematic, or it is a bit complex than the identification which we had done of the earlier case. That was much more easier process of identification. So with this, I end my today's lecture. Hope it was clear to you. Thank you. We take a break over here.